Welcome back. So we just had you answer a question. A car is driving in a circle at 20 miles per hour, and we want to know if the car is accelerating. So perhaps your first thought is that the speed of the car is the same the whole time, so the speed isn't changing. I'm going 20 miles per hour the whole time. But remember, the acceleration is the change in the velocity, not the speed. So the velocity is defined by both the direction and the magnitude of the motion, and that means that the direction of the velocity is changing. So as our car goes around in a circle here, so we're going, I guess, clockwise here. So as the car goes around, the direction of the velocity is changing, right? So over here the velocity is down, over here it is to the left, and here the velocity is going up. So another way of looking at this is that at the beginning, so here, the car is traveling to the right at 20 miles per hour. So in terms of the x direction, the velocity would be plus 20 miles per hour. And then as it goes around in the circle, then here our car is now going to the left. So here the new velocity would be negative 20 miles per hour in the x direction. So the velocity is clearly changing. The acceleration is pointed to the middle. So the acceleration here is perpendicular to the direction that the car is going. So that means that the acceleration is pointing to the center of the circle. So that acceleration, that's what's causing the direction of the car to change. This is called the centripetal acceleration, and we're going to talk about that a good bit in the unit on rotational motion. Now that we're talking about vectors in 2 dimensions, we can start to look at motion in 2 dimensions. So we've spent a good bit of time looking at one-dimensional motion, and this is going to work exactly the same way. We're going to be looking at the x component of velocity, of acceleration, of position, and then we're going to look at the y component of position, velocity, and acceleration. And the thing is, we can separate them and treat them independently. So 2-dimensional motion is really just doing one-dimensional motion twice. We have to be a bit careful here to make sure that we treat the motion in the x direction together and the y direction together and not get them mixed up. Remember, you did a homework question about a porpoise that was swimming between, I think it was 2 jet skis, and the idea was you look at the motion of the jet skis, which was accelerating at a constant rate, and you look at the motion of our porpoise, who was swimming with a constant velocity. So adding the 2D motion is pretty much the same thing. The y-dimensional motion is going to be something like the jet ski, and the x direction is kind of like the porpoise, and we just have to make sure that we don't mix up our jet ski and our porpoise. So now that we've moved to 2-dimensional motion, it's worth revisiting the different ways that an object can accelerate. So the magnitude of the velocity can change. So our first one here. So that just means our object can speed up or slow down, so both are examples of acceleration. The direction of the velocity can change as well, and even if the magnitude of the velocity stays the same, then the object is still being accelerated. So literally the question we just did, if the acceleration is perpendicular to the initial velocity, then your object turns. Also, both the direction and the magnitude of the velocity can change. So we can speed up as we go into a turn, or brake as we go into a turn. Both of those are plausible situations, and so that will change both the magnitude and the direction of our velocity. Okay, so we have another question to do. We have an object that is traveling to the east, and we know that because we are given this velocity vector. So our velocity vector here is pointing to the right, so it's pointing due east. We're also given that the acceleration vector, so the red acceleration vector, is pointing sort of to the east-southeast, so it's pointing both to the east and a bit south. So the acceleration tells us the change in the velocity, so the velocity will change in the direction that the acceleration vector is pointing. So we can split this up. So we have an x component of our acceleration, so we'll call this a sub x. And so that means that the x component of the acceleration points to the right, so that means that the x component of the velocity is going to increase. So that means our x component is going to get larger, so our object is going to speed up to the east. On the other hand, we have another component. So we have the y component, So we have our a sub y here, and so that's pointing down. And so that means that our velocity is also going to change, and it's going to pick up a component in the y direction. So that means that the velocity vector is going to pick up a y component, and it's going to be negative. So that when we add this new component, that means that we're going to be traveling a bit to the south. So we can treat this motion in the x direction to the east and west separately from the y motion. And we see now that our object is moving faster and that it has turned just a little bit to the south. Okay, so you have a quick question to do, and next we're going to look at projectile motion.